So in this video, I'll be breaking down the new release Realtime API by OpenAI, and I'll be kind of breaking down how this thing is configured, how it works, how it compares to what we had previously before with older voice providers. Then I'll also be kind of breaking down how you can integrate this thing with other applications, like how we can integrate this with Twilio, so we can build phone agents, so we can pretty much build, I guess AI that can interact with people with their phone. And I have this code that I'm gonna break down later, which is using OpenAI Realtime AI and using Twilio to simulate a phone agent we can kind of interact with and call. And then to kind of break down what is the Realtime API. Know what that is? That's I guess it's an API that allows you to access their speech-to-speech model, which will allow you to kind of have real-time conversations with AI, or I guess voice-to-voice or speech-to-speech conversation with AI. If you don't know what I mean exactly, here's just a quick demo. Just kind of check out what I kind of mean by voice-to-voice.
It's in a variety of different emotive styles, and it really has a wide dynamic range. So I'm going to fire up another demo for that. Yeah. Hey, ChatGPT, how are you doing?
I'm doing fantastic. Thanks for asking. How about you?
Pretty good.
What's up?
So my friend Barry.
So you can kind of see that he's having a voice-to-voice conversation with AI. So I think the big thing is that what is the difference between if you what OpenAI just released and what other voice providers are already doing pretty much. So if you know VAPI or Bland, if you don't know them, I mean, here's VAPI here. What they are is just kind of like OpenAI. They're applications or software that allows you to have voice-to-voice conversation with AI pretty much. The big difference is that OpenAI is using their own models, where VAPI is using other people's models, using other models out there. They don't provide their own models, but so pretty much what OpenAI does difference between VAPI is, if I kind of show here, is that OpenAI is a pure speech-to-speech model, where voice providers like VAPI or Bland, they do this thing. They use this thing where they use 3 different models that kind of give you your desired output. To kind of describe what I mean, if you go to OpenAI's real-time documentation, they kind of mention it kind of here too, where it says how it works. And you can see they say previously, to create a similar voice assistant experience, developers had to describe audio with an automatic speech recognition model like Whisper, pass the text to a text model for inference or reasoning, and then play the model output using a text-to-speech model. This approach often results in loss of emotion, if accents plus noticeable latency. Okay, so this is what is saying that's what typical or the models like voice providers like VAPI do, and to kind of explain more on this is that what happens when you're usually what VAPI and these things do is that they integrate these things with some type of device, like maybe your phone, so you can have phone calls with AI. And what happens is that when the person talks through the phone call to the AI, it's going to transmit the speech or audio to the voice provider or the AI. Now, what happens is that it actually turns the speech to text first. It goes through a model that turns the speech into text, and this is usually called a transcriber model. And these models are usually used to kind of take describe like something like phone calls into text. So maybe you want to take a phone call that you had with somebody and describe it to text or transcript so you can read, or maybe you want to take a YouTube video and transcribe it to text. These are what these speech to text models are usually for, and examples of that is kind of like DeepGram. You ever heard of DeepGram? That's one example of a speech to text model. But we turn this. The reason why we want to turn this to speech and text, because we want to pass this through an intelligence model. So we want to do text to text pretty much, but we want to transfer this to an intelligence model. Why do we do this? Well, audio there isn't really an audio to audio model out there, or a model that deals with speech that's intelligent enough to have conversations with somebody, that's intelligent enough to do reasoning and all that. So there's not models out there trained at that level compared to actual text LLM or something like ChatGPT or Claude or something to actually generate these responses, or generate using like a high level amount of reasoning and so on. So usually what you want to do is that you want to pass. This is the reason why. So the reason why we want to do this is because we want to pass the reasoning to a text-to-text LLM to handle this. Because again, there are other models out there that can usually handle it. So what we'll do is that they'll take the speech to text, and then it'll take the text to intelligence model like ChatGPT, so it can generate a response based on the speech or audio that the inquiry that the person mentioned to the during the phone call, or during to whatever application you're using. And again, examples of this is usually ChatGPT or Claude. And what happens is, after it generates the reasoning, after it generates the response, it takes that text and does it, and transfers it, or process it through a text to speech model or a voice model. So what these voice models do is that it can take text, and it can translate back to audio or speech based on whatever accent or whatever set type of way you want the voice to sound, pretty much. So I go here to examples. One example is 11 Labs. I go to 11 Labs. You can see that there's speech here, and then you can see that there's like the language it wants, English, Arabic, and stuff. And then you can see there's a different set of voices. So if I click Lily and play this.
The 11 Labs voice generator can deliver high-quality, human-like speech.
So you can see it can take speaks, it can take text, and then translate to audio or speech based on whatever accent or whatever voice you want. And these voices are usually trained. You usually have to train these voices. So usually you can train your own voice in your own voice and have it translate in your own voice. But usually you have these voices trained, and you have 11 Labs will have a preset of voices you can choose from that they've already trained themselves, pretty much. So that's how these typical voice providers usually work. Now, how OpenAI works is that it's pure audio input and then audio input, then it's pure audio output. So it's input and output, all pure audio. So there's no middleman. You don't need to put this through a intelligence model. You're just doing pure audio and pure output. So what's the pros in this? So first of all, there's a decrease in latency, since you're not taking this whole thing, your whole input through 3 different models. Instead, you're just going through one model. I mean, there's a major decrease in latency see in that, and you can just completely stream the the response, the input, the pretty much output back to the user, pretty much. So there's a major decrease in latency because you're just using one specific model to handle everything. And then there's things like it can detect and change emotions. So think about it. How this usually works is that it's the AI, when the AI is generating the response, when it's figuring out how to generate the response to your user's audio or user's speech or user's input. Remember, it's not taking the speech; it's taking the text. So if the user started like screaming or something, or the user started crying or something, it won't know that because it's not taking the audio. It's just taking text. The text won't have the emotional context to the conversation. Now, if the user, it might be able to determine if the user is angry or something based on certain words. Like if the user was cussing out, it might be able to determine that the user is angry or something, but it can't do it through actual voice compared to an audio model that will be able to detect emotion and also be able to adjust its emotion to the user, because it's taking pure audio input. It's not losing that audio context. Same thing where you see me say recognize non-speech sounds. So like if I was playing like a guitar or something, and the AI was listening to the guitar sounds or something, again, it won't understand that because again, the audio is turned to text. So if you start playing guitar sounds, it's not gonna be able to understand what you're playing in the background. AI, audio to audio can understand that, and you'll see. I'll show you examples of this, but text to text won't be able to send it because again, it's losing the audio context that it has since it's using text to generate a response. Same thing with distinguished homophones. So imagine words like live and live. They're spelled the same, but they have two different meanings. You'll say live like the football game is live, or the concert is live. Or you say live is like I live in this house or something. They're spelled the same, but two different meanings, and they're pronounced differently. Now this type of a text to text model won't understand that. Like because again it doesn't have the audio context. It doesn't understand how you pronounce it or anything. It just sees the text, and text wise again it's spelled the same. So unless it has extra context to understand the meaning of the word, it's not gonna be able to differentiate between those two words, since text wise it's spelled the same. Audio can actually differentiate between these two different type of words. So I'm gonna kind of show you examples of kind of much difference between VAPI and how OpenAI works, so you can kind of get more of a feel of what I mean pretty much. So I'm gonna do some demos on kind of give you, like I said, I want to give you a better understanding of how VAPI, how the difference between something like VAPI and something like OpenAI, they're just audio. So the first test I'm gonna do is show you how OpenAI is able to distinguish between, I guess, homophones like live and live and stuff, where VAPI can't really do that. So I'm going to run this code. This is code I'm going to break down later, but I'm going to run it now to kind of run a test on it. I call a phone number on my phone.
Hello there. I am an AI voice assistant that will help you with any questions you may have. Please ask me.
Can you use live in the sentence?
Sure. Here's a sentence with the word live.
No,
Many
live.
Dream of.
I said live.
Apologies for that. Here's a sentence with live. They decided to live in the city to be closer to their work.
No, I said live. Say live. Do a sentence with live.
Sure. The band will perform live on stage tonight.
Okay. Now do a sentence with live.
Certainly. They will live in the countryside for a quieter lifestyle.
Okay, thank you. So you see how it kind of messed up a little bit. I think some reason the OpenAI it's still kind of beta. It's kind of nerfed. I don't know, especially compared to the demo. It's the OpenAI show. It's kind of nerfed, but you see how it eventually got it. Now let me try with VAPI.
Hello, this is Ava. How may I assist you today?
Say the word live in the sentence.
Hello, we are now live. This is Eva. How may I assist you today?
Say the word live in the sentence.
The word live is an important word in the English language.
No, say live. You say live in the sentence.
In this sentence, I am saying the word live.
No, use live in the sentence.
I enjoy watching Saturday Night Live on television.
No, use live in the sentence.
It's exciting to watch musicians perform live in concert.
No, I said use live in the sentence.
I apologize for the confusion. In the previous sentence, I used the word live in the context of a live musical performance.
Yeah, but I want you to use live in the sentence.
The word live has multiple meanings, so I want to make sure I understand your request correctly. Would you like me to use live in a sentence as a verb meaning to reside somewhere, as an adjective describing something happening in real time, or perhaps in another context?
Okay, so you can see how it acts as the context of it. So it's VAPI is still able to do this. I think it's the AI smart enough to kind of figure out I'm using context, but it acts as, you can see how it acts as the contextual meaning to make sure that it knows which live to use pretty much. So that's one thing. Then let me there's also app you can use. So you can use it on your computer itself. You can use voice mode. So let me play around with this and see if I can make it laugh and stuff. Go here, go back. Let me create a new one. Can I create a new one? Okay. Hey, what up?
Hey there, not much. Just here to chat. How about you? What's up? I'm all ears and ready to chat. What's on your mind today?
I'm gonna tell you a joke.
Great, I love a good joke. Lay it on me.
After I tell you a joke, can you laugh for me?
I can't actually laugh, but I can definitely respond with something that sounds like laughter. Go ahead, tell me your joke.
Okay, why did the chicken cross the road?
Why?
Because you need to get to their side.
A classic. Always a good one.
Okay. So you can see that it was able, even though it said it couldn't laugh, it was able to give a little chuckle and laugh and stuff. Now I'm going to try it with VAPI and see how it kind of performs with that.
Hello, this is Ava. How may I assist you today?
Can you do I'm gonna tell you a joke, and after I tell you a joke, can you laugh for me?
Of course, I'd be happy to listen to your joke. Please go ahead and tell it, and I'll do my best to respond appropriately. I'm all ears.
Why did the chicken cross the road?
Chuckles. Okay, let me think about this for a second. Did the chicken cross the road to get compressed on the...
It said chuckles, so it can't actually laugh. It just said chuckles, so it can't do that more laughing sound. It just said chuckles, because again, it's more of a text to speech. It's generating the response through a textual context. So let me see if I can play around with more. It's still in this beta phase, so it's kind of nerfed. So it's not perfect. I'm gonna show you demos that are gonna be more perfect in showing what this capabilities do. But let me see if I can get it to do other things. I might as well try and see if I can get it to do other things. Let's see. Oh, so I'm actually still recording this. No, let's do here. Can you say I like chocolate milk in a British accent?
I like chocolate milk. How was that?
Okay. So we did that. Then let me see if I can go here and...
Sorry, I didn't catch that. Could you say it again?
I muted it. Exit out here. Then let me go to VAPI and see how it performs comparative.
Hello, this is Ava. How may I assist you today?
Can you say chocolate milk in a British accent?
Sure, I can try to say chocolate milk in a British accent. Here it goes. Chocolate me UK, said in my best attempt at a British accent. How was that? I'm not sure how accurate my British accent impression is, but I gave it my best shot.
It didn't. I mean, I'm not really British. It didn't sound as smooth, or I didn't really get the accent as much. I think let me show you. Let me show you some demos with that for OpenAI. They kind of give you a better showcase of how powerful this thing is. Let's see. Real-time Chinese. Speaking Chinese.
I want you to really get into it and scream when a goal is out. Hey, I want you to act like a sports commentator commentating a soccer match. And I want you to really get into it and scream when a goal is scored and get really excited.
All right, folks, we're in the final minutes of this intense match. The home team is pushing forward, passing with precision. The striker's got the ball. He's weaving through the defense. He shoots. Goal!
So you rarely see VAPI being so, I guess, fluid and emotional. So I guess that's one really good example of how powerful these audio to audio models are. But let's see, I think there's other better examples here. Okay, this is beatboxing.
Absolutely. Birthday rap. No time to nap. Light the candles. New scandal. Clap, snap. Wrap it up. Happy birthday. What's up?
Add more beatboxing.
Birthday rap. No time to nap. Light the candles. New scandal. Clap, snap. Wrap it up.
So that's beatboxing. Let's see what other. Let's see here. Speaking in a certain way.
How you dey?
I'm like, yeah, right. So I just tired. I see just the work since morning. So I just the reason you know where I fit get better man buy for this town.
I sabi one place we good well. If you fit waka go one local market, them get better amala joint for there. You go enjoy am with correct ewedu and bakery. Now so the thing go sweet if something you go forget say you tire.
Oh man, I don't want to forget to. But you know how much you go sell am so?
E no too cost like that. For that kind local market, you fit see one.
You see how fluid and fast it is compared to VAPI. It's super fluid. And then this is it trying to sing.
Want to start us off? Whenever you're ready.
Eleanor McBee picks up the rice in a church where a wedding has been.
Lives in a dream.
Waits in the window, wearing a face.
So that's it trying to sing to the beat. Let's see what others. And this is
Help me tune my guitar. We're gonna tune by.
This is it trying to it's actually understanding the guitar, I guess the guitar tunes or the sounds the guitar is making, and is giving the person, I guess, insight on how to improve it and stuff.
Here.
Absolutely. Let's get your guitar in tune. We'll start with standard E tuning, which is E, A, D, G, B, E, from the thickest string to the thinnest. Ready? Let's start with the low E string. Pluck it and try to match this pitch. Let me know if you need to hear it again.
Okay, what do you think about this one?
It sounds a bit low. Try tightening the tuning peg.
That's one big thing. It actually understands audio like that, so that's pretty huge. So I mean, there's a bunch, and they're gonna eventually add vision capabilities to it, but you can kind of see a bunch of how fluid and how the you see all the potential with using something like this audio model compared to what voice providers are using right now, which is they're using three models, and they're using text to actually generate response, so they're losing a lot of the audio context on the audio context pretty much. Okay, so now let me go and actually break down this code. So what we're gonna go over today is how to kind of integrate the OpenAI Realtime API into your phone pretty much. So pretty much people can call your phone number, and then they can actually interact with the OpenAI assistant through a phone pretty much. So this is gonna be integration with Twilio. So first of all, I want to kind of show you that one VAPI also does have they do have the open real-time API available. So this is something they have recently added. So if you want to just set writing code, if you want to kind of test it in something that's already pre-built, which VAPI is, you can go play around with it in VAPI pretty much. Now for more developers or people that want to have more full control over the API and stuff, then this learning how to build it from scratch would be ideal for you. So I'm kind of go over the code for this, and this is from, if you go, what helped me build it is the tool. There's two things. There's a Twilio documentation, OpenAI Realtime API. And let's see. So I'm gonna I'm gonna have a GitHub with we'll have all these links that I'm showing through the video, but it's not the Python one. But here's a Python one. So this is the repo. So here's the repo of their Python, and then they also have the tutorials. Let me go duplicate that real quick. Here we go. So here they have a tutorial. So they have this and they have the repo. So these are the two resources that I use to help kind of build this thing out. And I'll definitely put that. I'll have a Get repo with the code and all the links that I've kind of showcased here. But to kind of go over the code, because I'm going to break this code down, so you guys kind of understand how this works and the logic of this. So the first thing here is that we're just importing a bunch of libraries. Fast API for our endpoints. We're using Twilio because we're going to integrate this and connect this with Twilio. We're using stuff like Websockets, basics for encoding, JSON. So we're gonna be using JSON format around here. So we're just importing a bunch of libraries because we're gonna use their functionality throughout the code pretty much. And then you got basic login. You have the OpenAI key integration, which you'll set up if you're using Replit, you'll set up in your secrets. If you're using like VS Code, you'll have a file called .env that'll have your secret inside it. But they can kind of continue going with this. We have our system meshes. So this is our prompt that our AI will be using. This will be cited. We're going to use this variable later on in the code, which I'll mention. Then we're choosing what voice we want our Open Real-Time API to use. And I think OpenAI right now, their API has only a few voices available. I think it has all these voices. So it has
in the heart of the city, there is a large park where people go.
Then you have Aloe, which is the one I'm using right now.
The sun rises in the east and sets in the west.
And then you have stuff like Shimmer.
The beach was a popular spot on a.
So these are all the kind of voices that AI has available, pretty much, or Open Real-Time has available. I think they only have like 4 or 5 voices completely available. So we have these are the log event types. Again, these are gonna be. I'm gonna go deeper into this in my later code, or explain more of it in my later code. But these are just events that we're gonna log, or events that OpenAI uses that will help us trigger certain actions in the code. So I actually go to the OpenAI Real-Time API documentation. API docs. Click here. Okay, and then I should be able to go to scroll down, and it's mentioned these events like input buffer, all these events I mentioned. But particularly if I go down here, we'll have all these client events and stuff like input audio buffer conversation. These are the events that I'm kind of referencing, and these are things that I'll discuss more later on in the code. But then after that, I'm gonna set up a fast API, which will be used to set up our endpoints. You see here that will be endpoints to be endpoints Twilio will be interacting with. And then I have this endpoint right here, basic endpoint. This is just for I guess a basic the health check pretty much. So this is just to make sure my everything's running pretty much. So it's a basic health check. So a basic health status page pretty much. And then I have this endpoint called incoming call. So this is the endpoint Twilio will be interacting with, and I'll show you how I've set up in Twilio a little after. But this is the endpoint that Twilio will be interacting with. So it will be interacting with, so if I go here, it'll be interacting with this URL, but it'll be this URL / incoming call. So I'll show you later. This is the endpoint that I'm going to copy and paste and give to Twilio, to my Twilio phone number, so it can actually interact with the OpenAI. You can actually interact with the OpenAI Real-Time API. But pretty much what you have here is that you have you're creating a responsive variable equal to a voice response object. This is something I imported from Twilio in the top, and to understand what it kind of does here, what this response is kind of doing here, here's the documentation for it. So what Twilio has is that it has this thing called Twilio ML, which is their markup language, which allows you to write a set of instructions to tell kind of Twilio what to do when they're during a call, or when they receive an incoming call. What should they do? What actions should they take? Pretty much. So one thing here you can see is that they use voice response. They set to a response object, a response variable, and they do something like response.say. So they're telling for when a call starts, they're telling Twilio to say hello, pretty much. So like right here, for example, if I copy this and then I go paste it here, what will happen here is that it will have Twilio say this, and then waitable, then say this once the call connects. And if I can actually test this out real quick. Let me see if I can test it out real quick. Run.
Please wait while we connect your call to the AI voice assistant, powered by Twilio and the OpenAI Realtime API. Okay, you can start.
So you can see that it actually repeats that. So these are just the setting instructions we're giving Twilio to do when a call happens. And what's happening here is that we're setting up a connect object. We're using connect. If you go, I can actually search this up. Twilio connect. Twilio connect. Oops. And Twilio connect. So this is not it, pretty much. Here's it. Here's connect. So what connect is pretty much doing is that it's gonna connect Twilio to our WebSocket pretty much, and I'll kind of go deeper into more what our WebSockets are, but it's gonna connect. It's gonna help us connect to our WebSocket, which is gonna be handling. It's how we're gonna stream the Twilio audio to OpenAI, the OpenAI Realtime API, and how we're gonna stream the OpenAI Realtime AI responses back to Twilio. So I'll go deeper into that more, but what we're doing here is that we're setting the URL. We're setting the URL where we want to kind of receive data from. So this is the URL that Twilio will stream the audio to. The audio. So when we're speaking, this is the endpoint Twilio will stream the audio from, and this is the endpoint where Twilio will receive the audio from OpenAI from. And you can see our endpoint. If you go down here, you can see this media stream endpoint right here. And then what host is, like I showed before, is that host is just this. So host is just this, and then it's gonna be this /media stream, and that code has how we handle the audio that audio Twilio gives to us, and how we are gonna send audio to Twilio pretty much. And then you have response on the pen. So what this is doing is that these, like again, I said, response is used to give Twilio instructions. These are just instructions to tell Twilio once the call starts that we need to connect. We need to connect a WebSocket to this endpoint pretty much. So now this is where I kind of go and discuss kind of what I mean by WebSockets and so on. So what are WebSockets? So if you look at our code here, like I mentioned before, we have this connector stream, and we append it to a response. And like I mentioned before, what the response does is that it gives Twilio instructions on what to do. And if we go to Twilio documentation, you can see that this is Twilio ML. This is the format that gives instructions, like I mentioned before. And we see connect here, and we go over here, we can see stream. And what it says here is that it starts a bidirectional media stream. So that's what a WebSocket is. It's a bidirectional communication, but not just a bidirectional communication. It's a bidirectional communication that's long lasting. they kind of give you more insight on what I mean. Think of how typical communication works between, I guess, the internet or two devices. A client, like we can call that client or server. So Twilio is the client, and then technically OpenAI is the server. And what Twilio is doing is it's sending a message to the server, OpenAI, so it can generate a response to that message, that Twilio message, the audio that the user sent, and generate a response back to it and give it back to Twilio so it can output that to the user. And how that usually works is that there's code somewhere, there's code somewhere that's running that will trigger the API based on a certain event or something, will trigger the API, and that will cause the client to send a request to the server. And then after that, based on the request, the server will send a response back to the client. And then when that happens, the connection is closed. Now, if I want Twilio to talk to OpenAI again, or I want the client to talk to the server again, I have to trigger the API call again and send a request to the server, and then have the server send the response back. Now, this really isn't effective for applications where you might need bidirectional communication. So for applications where you will need a server sometimes to send a request to the client, and the client send a response back to the server. And it also won't be handy for, I guess, very latency intensive applications. So applications that need a fast response time, like a two-way phone call communication, we need speed, and this wouldn't be the most effective way to have the AI give the AI fast responses to the user during the call. So this is where WebSockets come in. Again, like I mentioned before, WebSockets are long-lasting bidirectional communication. What does that mean, or what does that give advantage over than that typical HTTP request doesn't have? Well, two things. One, again, it gives bidirectional communication. What I mean by that? Imagine if you have, I guess, you're playing a game, an online game, and you have the client, which is your device, your game device, and then you have the server, which is the online server, the game server. So your client or your game device might need to send a request to the server where it needs to give the server your position, your position, so it can show other players your position, or when a player is located where you're at, the server can show that you're in this location pretty much. But in the same case, the server will need to send you're on the online game, or the online server will need to send a request to the client, the device, on the other players' positions. So then you know where those players are located, and they show up in the map of the screen when they're around your area, pretty much. So that's what I mean by bidirectional communication. Then what I mean by constant communication or long-lasting communication. What I mean by that is, like, again, think of a live stock app. So what will happen is that instead of having something triggering an API to push stock data to your application, to your stock application, maybe like stock prices. If you have a WebSocket, what we'll have is that you will have a consistent communication that's always open. That maybe you have it manufactured in a way where anytime there's any updates to the stock prices, automatically your stock application will take that and update stock pricing. And that's what people usually do if they want something that's that's real time, that's 100% accurate, it's 100% live, it's consistent and realistic, or consistent and factual compared to the actual live data. That's what people would usually have. And to kind of give you more of an example of this, or a real example to kind of explain it, think of like a phone call. So imagine you're calling somebody, and when you dial the number and you call somebody, that triggers an API call. And after the user picks up the phone, you'll send a request, and that request will be you talking to maybe you called your friend. You'll say, "Hi, Carl." That would be the request. And after that, your friend Carl will send a response back and say, "What up, David? How has your day been going?" Now, after that, the call disconnects. And then if you want to speak with your friend again, or you want to tell your friend something else, you have to call him again and then say something back to him again. So this call follows two rules. One, there's only a two-way message here. There can only be two messages in this call before the call ends. the message from the person, the caller, and the message from the person that's getting called. So, and after that, the call disconnects. And then the second rule is that only the caller can respond first. So the person that's getting called, like if you're calling your friend can't say anything until you say something first. So it's a one-way direction, one-way communication. Your friend cannot start off the conversation. He always has to wait for you to say something before you send a response back. So it's not a two-way communication. It's only one way. Now, how a WebSocket will work is that, again, you'll dial up the number and call someone, and that will start up the WebSocket communication. And now you can say, "Hey, Carl," and then your friend can say, "What's up, David?" And then the conversation can still continue. Then you can say, "Hey, nothing much." The conversation can still continue after that. The call won't immediately disconnect after your friend replies. The call will continue as long as you want, because WebSockets are long lasting. They don't just end after one conversation or one I guess action. They continue until you want it to end. So, and then second, what happens here is that after we say what's up, David, how your day's been going, there's some silence. Carl doesn't respond, or the caller doesn't respond. So David says, "Hey, then Carl says, 'Hey, David, do you catch what I said?'" So Carl can still send a response back to Carl, or send a request to Carlo, even though Carlo hasn't responded yet. So again, it's bi-directional, where David doesn't have to wait for Carlo to say something to respond back, or the friend doesn't have to wait for the caller to say something to respond back. He can immediately send a request back to Carlo if he doesn't respond, because again, it's bi-directional. That the conversation can happen two ways, so either one can start the conversation. And after that, Carl just says, "Sorry, got distracted. My wife is asking me to help with the groceries. Call you back in 10 minutes." And then David says, "See you in 10 minutes." And then Carl ends the call. So the WebSocket will close anytime you want it to close, pretty much. Or anytime an error happens or something like that. But pretty much is that it's a long lasting, where you can have as many messages. You can send as many messages as you want before the call actually ends. So think of this. Imagine how long it would take for you to send a message back to your friend. If every time you want to send a message, you have to send one message, wait for a response back, and then the call disconnects, and you have to dial the number again and call them again to send a message. Compared to you just stay on the call, and then both of you guys can communicate without having to end the call to send another message. I mean, which one would be way faster? The second option. So that's how WebSockets can really benefit the latency side. They're way more effective when it comes to speed, because how it works is way more fluid, and it's way more effective than making multiple API calls, and making an API call every time you want to send a message. So that's kind of a breakdown of kind of how the WebSockets work. So going back to the code, let's go break down pretty much media stream endpoint. Okay, this is, as I mentioned before, this is the pretty much the endpoint that we're connecting to. So Twilio is streaming all this data to our media stream endpoint. This is what's going to handle how we receive Twilio messages and how we send Twilio messages. So kind of continue where I left off. Let's kind of go through, like I said, how we kind of receive and send Twilio. We receive Twilio audio and send it to OpenAI, and how we generate response and send it back to Twilio. So here we are creating our WebSocket endpoint, which is media stream, and then we're just connecting. We're just connecting to the OpenAI's WebSocket. So this is where we're gonna kind of send messages to, send Twilio's audio message to. So OpenAI can generate a response, and this is where we're gonna pull out the audio message so we can send it back to Twilio, and it can output it back to the caller. So here, this is OpenWS. This is going to be the variable that we're going to use to signify the OpenAI webhook, pretty much. And then we have here we have right here is that we're also going to call this send session function and send session update function, and to kind of go over what that function is going to do. We go down here. So let's see, we have this. This is just this is pretty much just setting our parameters for our OpenAI session or our OpenAI Realtime API. So it's gonna turn on server VAD. This is gonna be needed for handling interruptions. This is gonna be the audio format we're gonna be using. We have to use this format because this is the format Twilio accepts. And then remember before this is the voice and system measures that we set before. These are the what kind of I guess the inputs that we're going to send to outputs that AI is going to deal with. So it's going to be dealing with audio. Right now we said the text to audio is mostly going to be dealing with audio, and then this is the temperature. And then what we also have here is that also to kind of see that if you ever want to look at documentation of on the events like send and session.update, we can always check them here. And you can see right here, the first thing is session.update, and this just tells you send this event to update the session's default configuration. So this is to alter your real-time configuration. And then we go here. Then there's also another function that we're calling it. So this thing is not just updating the system configuration. Is also running another function called send initial configuration item. This is what we're going to use to actually trigger our first message. So instead of having the AI wait until the user says something to generate a message, we're going to have the AI send an initial message to start off the conversation. And you can see here our send initial conversation function. And what we're doing here is we're creating a variable called conversation item. And we're setting this equal to event to I guess an object, and you can see here we're citing the. Oops, let me go back. How do you go back? Control Z. Is it? History. Go back. Send conversation item. Okay, send it here. Okay, so we're using this conversation.item.create event, and we go to our documentation again. You see conversation item.create. What this does is that it adds a new item to the conversation context, including messages function. So what this does, it's gonna add pretty much a message into the conversation. And you actually, if you go to their to other documentation they have here, they have this right here. And you can see in conversation, you can see the messages, and you can see them labeled as items. So what item it stands for is that it stands for the messages that the AI receives, the user messages, and the messages that the AI outputs, the assistant messages. So we're adding a new message into that buffer, or pretty much into that buffer, by using conversation.item.create. And then we have a bunch of parameters like the type, a message. We have the role, which is user. We're gonna send a message as a user so we can trigger the system, create a response. We have the input. I think when it says, I'm not 100% sure of this, but I think when it says input, it's not like the actual it's not saying to give me like a text output or anything. It's just telling the value that I'm passing, like what value am I passing? What value am I going to passing to the AI as input? So if I did input audio, this would be actual audio instead of actual text text value. But since we're just trying to trigger audio response, we don't need a breakdown or looking at any audio. We can just give it a text a text input so it can generate a response based on the text input. And so we're pretty much just creating a prompt for it to greet us as soon as the call starts, pretty much. I didn't spell that wrong, hope. And if you go here, again, you go here, you can see all the kind of variables you can use here. So you got type, you got status, you got role, you got contact, you got ID. So you got all these values. Let me see, content item, content, and let's see input onto. Okay. And then after that, we use we reference that WebSocket variable that I mentioned before, and we send this event into the WebSocket, or we send this object into the WebSocket. And after that, we send the response.create event to the WebSocket. So this is supposed to trigger it to actually create a response based on the message, pretty much. And if we go back to documentation, you can see response, you can see .create, and you can see here the event instructs the server to create a response, which means trigger the model. So this is used to actually trigger the model to create a response. So this is how we can kind of trigger it to create a first message as soon as the call starts. Then going back here, we have a couple of variables. We have to set up the stream SD. This is just the unique SD value, or I guess ID of the Twilio WebSocket or Twilio stream. We have the latest media time set. This is time set. A lot of these here are what we're going to use for interruptions, which I'll discuss later on. But we have the latest media time set. This will just return the latest time step of the call. So as when the call when the WebSocket starts, or when the stream starts, compared to where we're currently at in the stream, that will just give us the latest time, with the time frame that's pretty much passed between that time. Last system item will just give us the unique identifier, or I guess the actual last message our OpenAI assistant pretty much sent. So what OpenAI Realtime sent. Mark Q is just to kind of check what messages are in the queue. So I guess how OpenAI Realtime is gonna be doing it is gonna be sending these messages into to Twilio through chunks pretty much. So it won't send it all at one time, we'll send it through chunks. And Mark Q is just gonna be checking what messages are still left for OpenAI to kind of send. Then response start time step is when the response was first generated and started getting sent to Twilio, pretty much. That should be a response start time set Twilio. And then right here we have our functionality that's actually this is how we deal with receiving audio data from Twilio. So what we're gonna do is that we're gonna check if there's any messages sent to Twilio in the WebSocket. This is usually be in JSON format, and then we're gonna check if the event equals media and if the Open WebSocket safeguards open. So when it says the event equals media, these are Twilio events. These are Twilio events that kind of identify what's kind of happening in the stream. So if you go down here, this is media. This is the media event. This is the media, and what you have here, what media is that this is when pretty much when Twilio sends raw audio data. So that's when this thing will be kind of when this event will be kind of triggered, or when this Twilio will kind of return this event when there's when it has sent raw audio to our OpenAI WebSocket. So when we receive audio from Twilio, we're gonna set the latest media timestamp, so we can have the pretty much the time stamp when this raw audio data was sent, and then we're gonna create an object called a variable called audio append. We're gonna set this event to input.audio buffer.append, and what this does is if I go to here to see auto append, what this does is allows us to store the input audio. It allows us to store the input audio that we're going to send to the OpenAI WebSocket. So again, this is going to be a link. I'm going to link this in the GitHub with all the code and stuff, so you guys can access all these resources. But yeah, this is what's going to let us temporarily store the input audio. And then we're gonna receive the data, the audio from Twilio, so we can actually send it into OpenAI WebSocket, OpenAI Realtime API. And if you go to kind of Twilio here, go to media, and this should be .payload. So this is the raw audio encoded in base64. So again, we're accessing the raw audio from Twilio, and then we're gonna send that audio to the OpenAI WebSocket, as I mentioned before, and then we also check if the data event equals start, and we go to the Twilio documentation. Start is when when the stream the stream started. Once as soon as the stream starts or is connected, it will send a start event, and when it sends a start event, we're just restarting all the values. We're just restarting all the values to none. We're just restarting the values back to their basically the values that they should be at the start, kind of. So refreshing these values. And then we have one else if the event equals mark. So we go to events. Mark will be. So it only does it through streams when the service is. So anytime when the service sends a media message, it sends a mark message to Twilio. Okay, so this is pretty much just for tracking, pretty much. So for tracking what messages have been kind of sent. So this is kind of for tracking. This will help us with interruptions pretty much. So what all it's doing is that if it gets a mark event, it's gonna remove a value from mark queue, and this will go over this more later. And then it just checks if the WebSocket is ever disconnected. It just prints out a log that was disconnected and then closes the OpenAI WebSocket. And then we have our send Twilio functionality. So this is the functionality where we actually send the audio or send the response OpenAI generate back to Twilio. So what's happening here is that we're checking if there's any generated messages from OpenAI and the OpenAI WebSocket. And then what we do is that if we see that there's a message in there, we check if the type or the event equals response.audio.delta. And what that kind of means, if I go back to the event type, which one was it? Audio. Okay, audio delta. So this event is always returned when the model generated audio is updated. So I think when the model generated response is created, or when it's it's updated, or when it's created, it will trigger this event. And then what we'll do is that we'll see that a message has been generated, and what we'll do is that we'll decode it from base64 and then encode it again. The purpose of this is just to make sure that just to recheck that's in the proper format. I'm not 100% sure this is actually needed, because again, if you look at the Twilio's documentation for its media, it says that it's already encoded in base64. So it should be the format should be good, but what this is doing is just rechecking and making sure that the format is proper and is good. And then we create an object called a variable called audio delta. This will have the media event, our stream ID, and then we'll have the audio payload that we created. So this is we'll have the audio payload that we took from OpenAI, the generate response, and then it will send it back to the WebSocket, so back to Twilio pretty much, so it can send that audio back to the caller or user. And then it's sending the value of response start timestamp / Twilio. So I guess this would be the timestamp of when the response was sent back to Twilio pretty much. So when the response was first started, when it was sent back to Twilio. And then it also gets the last ID. So it gets the ID of the last response pretty much. So the ID of the last response OpenAI response we kind of sent to Twilio. And then we go to the send and mark functionality. So the rest of this pretty much is related to kind of how interruptions will work for our application, or how it will work with OpenAI. So I'll go dig deep into. Okay, so continuing off and kind of breaking down how interruptions work for our application. So first we run this send mark functionality, and honestly, this marking functionality that AI we're using throughout the conversation. We can see that we mentioned it. We mentioned marking queue. We mentioned marking queue here. We mentioned it a couple times. We mentioned it here. So honestly, I don't have a full understanding of kind of the full concept, but this concept is what's going to help us handle interruptions. And what this concept is technically doing is that it's just tracking what messages have we successfully sent to Twilio. So anytime we successfully send a message to Twilio, it's gonna add this, it's gonna track this and add this to the Mark Cube query. But this is at the end of the day, the functionality of what it's doing is using for tracking of what messages have been sent and what messages have been sent or not, pretty much. And what we have here after that is that to check interruptions, we're always checking for this event called input buffer.speech.started, and we go look at the API events. What this does is that it sends to our servers that anytime a speech has been detected, it sends this event, or it triggers this event pretty much, and this event can only be triggered when we have server voice activity detection on, pretty much. And again, those are one of the parameters we set in our session. We turn that on. So yeah, what it does is it checks if she's started. If it has, it gets the last this is only for log. It gets the last response item to kind of log that out to see what type of what response was interrupted. But the main thing here is that it calls the handle speech started event. And what this does is that first it checks if there's anything in our mark QA, and it makes sure that there's something in the value. So again, I mentioned that this is for checking if a response has been sent to Twilio, but I think the main concept is to check if there's anything there's any other responses that need to be sent to Twilio. So checking if do we still need to send responses to Twilio? Because if it knows that we still need to send responses to Twilio, it can kind of clear that response, so it doesn't completely complete the response. And I'll kind of show you kind of a more visual showing to see what this, so you can understand what I mean. But once it checks that, it gets a elapsed time value by taking the last media time step and subtracting it from the response start time step. So that pretty much gets the value of what the current time frame is on our stream, or in our the stream, since the stream started, and what was the time frame or time stamp when the response started it, and it gets that to see how the time frame that has gone by since the AI first gave out a response, pretty much. And then show time is just for logging, pretty much. And what we do here, the main thing here is that we create this trunk event value, and what this is supposed to do is actually enable what it does is it truncates our response. So what it's pretty much doing is that it's removing the response that the AI still needs to give out to us. It's removing that so the AI doesn't continue response. So the AI kind of stops. So as soon as we interrupt it, the AI will respond. It will clear anything in its queue or anything that it still needs to output the Twilio, and it will clear that so it can stop talking. And again, if you go to the documentation, we go to truncate conversation item truncated. Okay, here you can see here that this event is used to truncate the audio. So this event is kind of used to remove the audio, pretty much remove any type of audio that we want to kind of remove, or the shorten the response, pretty much. And again, then we send this event to the OpenAI WebSocket, and after that we just clear everything to make sure everything is good, and we reset all the values, and then that's how our interruption kind of works. And just to kind of show you what I kind of mean is that imagine if your AI, OpenAI, is sending a full general response like OpenAI is better than VAPI because the true audio-to-audio model also brings far better latency and realistic conversations than VAPI. So imagine if OpenAI sends this full general response, and then imagine if it's halfway through. So what it's already told the user that it's OpenAI is better than VAPI because of the true audio-to-audio model, but it hasn't told them this. This is in the queue where VAPI, where I'm not VAPI, where OpenAI is. We have OpenAI waiting to kind of send this response to Twilio, so the client, the lead, or the caller can kind of hear that the rest of the information pretty much. And so right now it's said this OpenAI has been happy because it's true audio, but it hasn't said this, so it hasn't gave it the full conversation. So now what happens if the user starts talking and says, "What do you mean by true audio to audio model?" What's going to happen is that what our code or AI or OpenAI is going to clear this. Since the user is interrupted, it doesn't want to continue sending this to the caller. Since the user interrupted and it's speaking and wants to stop speaking, so what it does is that it will clear this out of its queue. So then it won't repeat that response back to the user. It will just completely stop response from this part right here. So that's kind of how interruptions work. And since that was kind of the basis of all the code, and I kind of gone all over that. Let me kind of run a demo, just kind of showcase it to you. So if you guys want to kind of run this code, again, if you take your domain, remember I mentioned I showed you guys this domain before that you get when you kind of host your code, and then you have your endpoint, the incoming call endpoint that I mentioned before. You add this here as you go to Twilio. You go to your active numbers. You click on your active numbers, and then you put this URL in when a web call comes in. And then now, if I go back to the code and I make sure it's running, I can go call it.
Hello there. I am an AI voice assistant that will help you with any questions you may have. Please ask me.
Can you describe to me what a speech-to-speech AI model is?
Sure. A speech-to-speech AI model is a type of artificial intelligence system that converts spoken language from one form to another. This typically involves taking spoken input, processing and understanding it, and then generating.
Okay, I understand that. Can you tell me, are there any real-life examples of this?
Certainly. Real-life examples of speech-to-speech AI models include 1. Real-time translation devices. Some devices or apps, like the ILI translator or certain features in Google Translate, can instantly translate spoken language from one language to another, allowing for conversations between people who don't share a common language. Virtual assistants.
Can you give me like an actual AI model that can do this? Like an AI model, not like an application, but an AI model.
Certainly. An example of an AI model designed for speech-to-speech tasks is Translatotron, developed by Google. Translatotron can directly
that's pretty cool. Right now I'm using this the OpenAI Realtime API. That's like it's an audio to audio model that OpenAI has recently kind of created, and it allows you to do kind of pure audio to audio. So you can build applications that can do audio to audio instead of doing it through three models, like doing TTS and I guess STT and all that.
It's exciting to hear that you're using OpenAI's real-time API.
Yeah, so that's just an example. You can see how it's pretty good at handling interruptions and not interrupting stuff. So yeah, that's kind of the end of it. Nothing much else to go through. I'll probably have other videos coming out. I'm gonna be writing articles that kind of, because this is a long video, I'm gonna be writing articles that kind of break everything down into parts. So you'll be able to see that in the description. And then outside that, I'll be making these other parts. These videos will be shorter, but I'm making other parts on how to integrate this thing with function calling and a vector database and stuff. So yeah.